Welcome to another edition of A for A levels. This is my tutor. Today we're going to go through mechanics. Summer paper 42. Let's go. The tram starts from rest and moves with uniform acceleration for 20 seconds. The tram then travels at a constant speed v meters per second in 470 seconds before being brought to rest with a uniform deceleration of magnitude twice that of the acceleration. The total distance traveled is 2.775 kilometers. Sketch a velocity time graph for the motion stating the total time for which the train is moving. From acceleration. V. 20 meter per second. Seconds. Okay, find V. So the area equals to 775. V over 2, 170 plus 200, 775. V equals 15 meters per second. Okay, that's it. Another one. Find the magnitude of the acceleration. Acceleration A equals to 3. Equals to 15 over 20 seconds squared. Okay. Coplanar forces of magnitude 20 Newton, P Newton, 3P Newton act at a point in the direction shown in the diagram. The system is in equilibrium. Find P and theta. Yeah. The diagram is given, so it's quite easy. Taking vertical forces, resolving vertically. Upwards, it is 4P plus 3P sine 30 equal P sine 30 downwards plus 20 sine theta. Sine 30 is half. So P equal 5P, sorry. 20 sine theta. Resolving horizontally to the left. 3P cos 30 plus P cos 30 equals 20 cos theta. Okay. 4P root 2P root 3. Cos 30 is root 3 over 2. So 2P root 3 equals to 20 cos theta. 1 divided 2. Sine theta over cos theta is tangent theta. 5 over 2 root 3. Theta equals to R tangent 5 over 2 root 3. $55.3 degrees. Okay, next 1 square plus 2 square. Sine square theta plus cos square theta is 1. So you have 25 p square plus 4 times 3, 12 p square equals to 20 square. P square equals to 400 over 37 p equal 437. 3.29. That's it. Okay. Particle of mass 2.5 kilogram is held in equilibrium on a rough plane inclined at 20 degrees to the horizontal by a force of magnitude T Newton, making an angle 60 degrees, a line of greatest slope of the plane. The coefficient of friction between the particle and the plane is 0.3. Find the greatest and least possible value of T. Okay. Now you can either go upwards or you can go downwards. Okay. So let's see going upwards first. F. As the friction weight is 25. Okay. This is the contact force. F equals mu R. So R is 25 sine, oops, not sine, cos 20. Okay. So it is 7.5 cos 20. So if it is in equilibrium, greatest or least is when it's limiting equilibrium, when the friction is greatest or equals to mu R. Okay, so T cos 60 degrees equals to F. This is resolving along the plane. Upwards is T cos 60, downwards is your friction plus your weight sine 30. Okay, so this T is equals to 25 cos 20. This is 20 plus 25 sine 20 over cos 60. $64.1 Newton. Okay. So if friction can also be in the other direction. So if it's in the other direction, then T cos 60 plus F equals to 25 sine 20. So t equals to 25 sine 20. I think you'll get the negative value here, minus 25 cos 20 over 60. Oh, I made a mistake again. F is 7.5 cos 20. Wonder. So this answer is wrong. So it's 31.2 Newton. This should be the largest value. Okay, this is 7.5. Now you can have a positive value. This will be your minimum. This will be your maximum. Okay, good. Small smooth spheres A and B of equal radii and of masses 4 kilogram and 2 kilogram respectively lie on the smooth horizontal plane. Initially, B is at rest and A is moving towards B. After the spheres collide, A continue to move in the same direction but with half the speed of B. Okay, find the speed of B after the collision. A, B. 4 kilogram, 2 kilogram. I like to model conservation of momentum this way. It's easier to see. Okay. A is moving towards B at 10 meters per second. B is stationary. After the collision, A 4 kilogram, B 2 kilogram. Let's say B is moving at V. A will be half V. Okay. So you need to find what the V is because you need to find the speed of B. So initial momentum is 4 times 10 plus the momentum of B is 0 equals to 4 times half V plus 2 times V. So 40 equals to 4V. V is equals to 10 meters per second. That's it. The third small sphere C of mass 1 kilogram with the same radius of A and B is at rest on the plane. B now collides directly with C. After this collision, B continues to move in the same direction with 1/3 the speed of C. Show that there is another collision between A and B. Okay. B, 2 kilogram. C, 1 kilogram. So now B is moving at 10 meters per second. After the collision, B, 2 kilogram. C, 1 kilogram. Let's say C is moving at V. So this will be V over 3. 1/3 the speed of C. So again, law of conservation of momentum. 2 times 10 plus 0 equals to 2 times V over 3 plus 1 times V. So here is 5V over 3. This is 20. V equals to 12 meters per second. Okay. So the speed of B meters per second, which is smaller than 5 meters per second, which is the speed of A. Therefore, there will be another collision between A and B. Okay. A and B coalesce during this collision. Find the total loss in the system due to the three collision. Okay, now let's put this. A. Now A will be moving at 5 meters per second, which is 4 kilogram. B, which is 2 kilogram, moves with 4 meters per second. Coalesce means they join together, A and B. So the total mass is 6 kilogram. Let's put the speed as V. The law of conservation of momentum, 4 times 5 plus 2 times 4 equals to 6 times V. 28 equals to 6V. V equals to 14 over 3 meters per second. Okay. After this collision, C will still be moving at 12 meters per second, which is 1 kilogram. So the total loss is the initial kinetic energy minus initial KE minus final KE loss. So initial KE is half times the mass of A, which is 4, times the speed 10 square, minus final kinetic energy for A and B is half times 6 times 14 over 3 square plus the kinetic energy of C equal. So the loss is 62.7 joules. Okay. Okay, let's continue. Question 5. Okay, car of mass 1,250 kilogram is moving on the street road. On the horizontal section of the road, the car has a constant speed of 32 meters per second. There is a constant force of 750 Newton resisting the motion. Calculate in kilowatt the power developed by the engine of the car. So the key here is constant speed. So forces are in equilibrium. Resistance 750 Newton. Therefore, the will also be 750 Newton, the driving force. Power equals to Fv equals to 750 times 32 equal 24 kilowatt. Given that this power is suddenly decreased by 8 kilowatt, find the instantaneous deceleration. Okay. So if the power is reduced to 5 kilowatt, then what is the driving force? Reduced by 8 kilowatt. So the power now, the force equals to power over speed. So if you reduce by 8 kilowatt, that means left is 16,000 watts. Divide the speed is still 32. Just to make sure. So it's 500 newtons. Now this is, instead of 750 newtons, it's now 500 newtons. So again, it's in question on forces. Resultant force equals to MA. So it'll be 500 minus 750 equal 1251. A equals 0.2 negative meters per second square. Okay. Another section of the road inclined at arc sine 0.096 to the horizontal. The resistance of the motion of the car is 100 plus 8V when the speed of the car is V meters per second. The car travels up this section of the road at constant speed with the engine working at 60 kilowatt. Theta equals to arc sine 0.096. Okay. Car is here. Weight is 1250. 12500. Friction is 1000 plus 8V. Driving force is 60,000 V. So you want the constant speed. So the driving force resultant force is 0. So your driving force 60,000 over V equals to 12500 sine theta plus 1000 plus 8V. So 12,500, 12500, 0.096, 1,200. 60,000 multiplying by V, this 12,500 sine theta is 1,200 plus another 1,000 V plus 8V square. Rearranging, you get 8V square plus 2,008, 2,200 V minus 60,000 equals 0. Solving this. So V is 25. Okay. A particle P moves in a straight line. The velocity V at time t seconds is given by these three formulas. Let's sketch the velocity time graph from 0 to 13.5. So in order to solve or do this question, you need to know the graph. So from 0 to 5, this is a linear graph, 2t plus 1. So it will start at 1, 1, and t is 0. T is 5, it is 11. Okay, straight line. 36 minus t square is a quadratic function with negative maximum. So when t is 7, v is, oh, okay, it's at the bottom already. T is 7, 36 minus 7 square. Or minus 40, minus 13. So this one, the graph will go downwards, minus. Okay. So 7 here, 7. So at this point will be 7 minus 13. Again, this becomes a linear graph. So when t is 13.5, so it goes up to 0. So that's it. You have the graph. Find the acceleration at the instant when t equals to 6. Okay. So you have to use the second equation, t equals 6. So the acceleration is dv over dt equals to minus 2t. T is 6. The acceleration is minus 12 meters per second square. Okay. Find the total distance traveled by P in the interval 0 to 13.5. Okay, first portion. Now you're finding the area below the graph. Okay. This point here is 6. So from 0 to 5 seconds. So the distance is this is a trapezium. 1 and 11. 5 over 2, 1 plus 11 equals to 30 meters. So from 5 to 6 seconds, you have to integrate. It is 36 minus t square. Five to 6. So this is 36t minus t cubed over 3. So this is 16 minus 216 over 3 minus 180 plus 125 over 3. This is 72. 252, 64. So this is 64, which is times 3, which is 192 over 3 plus 125 over 3. So the second part is 317 meters. Third part from 6 to 7 seconds. Now you integrate 6 to 7, you're going to get a negative value. So I'm going to integrate from 7 to 6 to make it a positive value. So this will be still the same, 36t minus t cubed over 3. 7. So again, this is the same. 216 minus 72. Minus 343 over 3. Plus 343 over 3 minus 6. Oops. 36 times 7. We went freeze a bit, 252. Okay. So this one is a bit small. 19 over 3. And the final part is a triangle. So the final part is 7 seconds to 13.5 seconds times base is 6.5 times 13. .25. So total distance travel. (73704). Bit of calculation, but you get what I mean. So it's finding the area below the graph only. That's all. So when you have a graph, you need to just find the area below the graph. Yeah. So if it's below the x-axis, you will get a negative value. But if you can find the area, you find the area. If not, then you just do an integration. Okay. That's it for now. If you like the lesson, like and subscribe. If you want the working, put your email on the comment section and I will email to you. That's it for now.